we're going to look at a nice geometry problem, which isn't super hard, but I think it's really aesthetically pleasing. So our goal is to find the shaded area that's given here. But of course, we need some information as to how we construct this figure. So let's suppose this outer object is a square, and we'll actually suppose that it's a unit square just to make everything easy, although this could be with a square of any length. And then to that square, we will mark the midpoints of each of the edges. So this is the midpoint between these two vertices. This here is the midpoint between these two vertices, and so on and so forth. And then we'll, like we just did here, connect midpoints to diagonals, and that creates this object in the middle. Okay, so now we know our setup. Now we need to know what sort of shape that we have in the middle there. So it looks like a square, but we need to argue that that is also a square. And so we'll do that by putting this in the Cartesian coordinate plane. So let's say this point here on the bottom left is the origin. So that'll make this point here the point 1, 0. So we're extending the x-axis down that way. This point up here will be 1, 1. And then this point here will be 0, 1. Okay, great. And then since we're choosing these to be midpoints, that makes this point here 1/2, 0. The point that's right here is, let's see, 1, 1/2. Up here we have 1/2, 1. And then finally over here we have 0, 1/2. Okay, great. And so now I'll start by arguing that this inner object is actually a rectangle. And after we argue that it's a rectangle, we'll argue that it's the special type of rectangle which we know as a square. Okay, so let's note that this line right here, which I'm pointing to in purple, as well as this line right here, which I'm pointing to in purple, both have a slope of 2. So let's write that down. We have a slope for both of these lines is equal to 2. And that's pretty easy to calculate just from the slope form, or the slope formula given 2 points. The change in the y-coordinate divided by the change in the x-coordinate. So in this case, we'll get 1 minus 0 over 1 minus 1/2. So that's 1 over 1/2, which equals 2. And then we get something fairly similar for the difference between those 2 points. Okay, so that's slope 1/2. And then we can similarly calculate the slope of these two lines as well. And we'll see the slope of these two lines is equal to -1/2. But then there's a standard rule that says lines are perpendicular if and only if their slopes are negative reciprocals. So not only have we shown that we've got 2 pairs of parallel lines, but those pairs of parallel lines are perpendicular to the other pairs by the fact that both of these are slope 2 and then both of those are slope -1/2. Okay, so now we've got a rectangle. And now that we know that we have a rectangle, we'll show that we have a square by calculating the vertices for 3 coordinates. So let's say we'll have the coordinates for this vertex, the coordinates for this vertex, and then the coordinates for this vertex. So that'll allow us to calculate the side length here as the difference between these 2 points, and the side length here as the difference between those 2 points. Okay, while we're at it, maybe let's give these lines some names. Let's maybe say this one here is L1, this one here is L2. So those are the 2 lines with slope 2. And then the 2 lines with slope 1/2, maybe we'll call those L3 and L4. Okay, nice. And then let's maybe name these vertices so that we have something to work with. Let's name this vertex A, this vertex B, and then this vertex C. Okay, so now we've got some calculation to do. So notice that A is on the intersection of L1 with L3. And then we have B is on the intersection of L3 with L2. So like I said, L2 with L3. And then finally, C up here is on the intersection of L1 and L4. So L1 intersected with L4. Okay, so that means we probably need equations for each of those lines. So let's work out each of those. So let's maybe work out L1 right here. Let's notice that L1 contains the points 0, 0, and 1/2, 1. Also, we immediately know that it has a slope of 2 based off of our previous discussion. So that means we have the equation of L1 is y equals 2x, because the y-intercept here is clearly just 0 as it goes through the origin. Okay, so now let's calculate L2. So notice that L2 also has a slope of 2, and then we can use the point slope form along with one of these points to calculate the equation. So let's see, we'll have y minus the y part of this point equals slope times x minus the x part of this point. So in the end, we'll have y equals 2x minus 1. So there, now we have an equation for L2 as well. And then let's fill in the rest. So let's fill in L3 and L4. So let's look for L3. So the slope is negative 1/2. And look, we're just given the y-intercept, which is 1/2. So that means L3, like I said, is y equals 1/2 minus 1/2 x. And then likewise, L4 is 1 minus 1/2 x. Okay, great. So now we have all of those equations of our lines, and we're ready to calculate A, B, and C as these intersections. So let's do those one at a time. So let's do A first. So like I said before, that's the intersection of L1 with L3. So setting the two y components equal to each other, we'll get 2x equals 1/2 minus 1/2 x, which tells us, let's see, that 5/2 x equals 1/2, which can be solved to get x equals 1/5. But then looping that back into one of those equations, we'll get y equals 2/5, which means we have coordinate 1/5, 2/5. So that's our coordinate for A. So let's maybe put a box around that so we can save it. Nice. And then let's find our coordinate for B, which is the intersection between L2 and L3. So let's see, that means we need to set 2x minus 1 equal to 1/2 minus 1/2 x. Now we can start moving things around here, and we'll get 5/2 x equals, let's see, that'll be 3/2, which means in the end we get x equals 5/3. And then we can loop that back into one of the equations for y, and we'll see that the y component is 1/5. So that means our coordinate is 3/5, 1/5. That's our coordinate for B. Great. And then let's see what we get for our coordinate for C. So like we said before, C is the intersection of L1 with L4. So that means we need to set 2x equal to 1 minus 1/2 x. So that means we have 5/2 x equal to 1, which means x equals 2/5. And then plugging that into either of those equations, we'll see that y is 4/5. So that gives us a coordinate as 2/5, 4/5. Okay, nice. Now, in order to show that we have not just a rectangle, but a square, we need to calculate the distance between A and B, and also the distance between A and C, and we'll hopefully get the same thing. And we'll just use the distance formula here. So let's see, the distance between A and B will be 3/5 minus 1/5 squared, so that'll be 4/25. So 2 squared over 5 squared, again from taking the difference of the two x coordinates. And then the difference of the two y coordinates squared is 1/25. So let's notice that those add to 5 over 25, which is 1/5. So the distance here is 1 over the square root of 5. Okay, so let's maybe put that in here. So we've just determined that this length right here is 1 over the square root of 5. And then maybe I'll just put right angles here. We know that these are all right angles from previous discussion. Now let's calculate the distance between A and C just to make sure we're good to go. So the difference in the x coordinates is 1/5. We have to square that, so that'll be 1 over 25, plus the difference in the y coordinates is 2/5. We square that and we have 4 over 25. But that's exactly 1 over root 5 as well. So that means here we have this is also 1 over root 5. But that means we in fact have a square, not just a rectangle, but a square. And we can easily calculate the area here just by squaring 1 over root 5 to get 1 over 5. And there we have it, the area of our shaded region. And that's a good place to stop.
Thanks for watching and sticking around until the end of the video. And since you're here, don't forget to gently press that like button, subscribe, ring the bell, and select all notifications to never miss a video. If you want to get your name in the credits like you see here, access the live seminar series, review videos before release, and more, go to patreon.com/michaelpennmath and become a Patreon member today. If you want full ad-free course content, subscribe to my second channel, Math Major. I've got courses on linear algebra, complex analysis, and proofwriting, among several others. And that's everything. Bye.